So here you obviously presume that there is sequence, right?
At first I didn't, yeah, but I read that part.
Yeah. But as we discussed, right, if you did it this way, then you could say the second step,
Yeah.
then we do a method and first.
Yeah, because just like you said, the things I hear related to the new, not like any of my conflict process. So just like this part is just more.
Yeah, that's fine. That's fine. Let me just. But then I think the first part, when we're talking about, you would want to drop all the new parts.
Yeah.
Right? So to drop all of that, which you have dropped initially, drop everything new. Then on the lead part, so why do you presume in your solution that yt is not also a function of yt1 as well? Why do you presume that the solution is not also a function of the length and the yt1?
Talk about that. And try to simplify it.
Yes. Right, but if t is non-zero, how can you possibly ever remove this dependency on the length term, right? I mean, think about a special case where t was 0.
Because BT also have BT minus 1, and if I assume that YT, BT, just like four of these things have interaction with each other. Because of the
Right, but still, I mean, think about a situation where p was 0. Right, so then you're telling me if p was 0, I could solve for yt just as function of vt. If t was 0, right, so I could of course do is I could do backward approaches. I could solve for this in terms of my beginning for yt minus 1, in terms of yt minus 2, yt minus 3, yt minus 4. But then it's not just a function of vt, vt minus 1, vt minus 2, vt minus 3, vt minus 4. And so even in that special case where p is 0, you could not express it just as a function of vt. Right? Because it's going to be, in that case, at least a function beyond vt, also the length, vt minus 1, vt minus 2, vt minus 3. And the thing is, of course, going to get even more involved when you have the future situation. So I'm afraid that your initial conjecture, right, that you express this just as a function of vt is not part of the solution. Right? That this is too interesting. Right? And that's where the problem does come in, because this is much easier, right, than anything that we would have done in the lectures where we said you split it into the backward part, forward part, get the mainframe that gives us the solution on the backward part, because in essence, what you're doing here is you set the coefficients on the backward part of the solution.
I get what you mean, yeah, but like maybe I think like because we have this kind of process a lot long, and this thing like PT once a million. And couple, but if you say like maybe you have been trying, but like so this thing can have more than just one given solution. Because maybe this is wrong.
It depends on the industry. So if it
Tí
is
phải
less
chụp
than
được
one,
chứ sao, thầy sửa xong
then
chụp
there's
được.
no solution. If E is larger than one, then you will have one of the same solutions. If A was larger than one, it's just close. Right? Because that's the back of the house. But the amount of data is only right if it's larger. But I would say none of those solutions are functional BT. Right? Because again, think about the presentation of these, right?
Em chưa em chưa có thả lại cái đàn này.
And you get parents also being because you could say, well, I can write down the function of BT2, but then
Để em cài lại đó.
silence it, right? And then at least you have silence across all kinds of units. So I
Tải
think
lại
you
bản
never
tính, tải lại mắt lắm.
just to resolve this problem. Whenever you have structure
Không
here,
đỡ nữa
that's
không? Nó nhỏ.
I mean, this has some value that give you some points. But if you ask me to write wrong, I would say
Tải cái đàn nghe mà giờ tải nhiều quá không biết nó nằm đâu.
only a structure. It must be a minimum also function of language. But it's more than that, because you also have the forward. Right? In the forward
Rồi nó
part, you
đòi
not
gì
just
nữa vậy?
solve the
Bán
vector
suy rồi.
equations, but the forward part is going to be a completely separate set of iterations that involves both YT and the BT. And so the reduction to BT is for sure not. I mean, if you have doubts, like just try to look at this special case where E was equal to 0. Divide the solution in the case where A is equal to 0. And show me that you can reduce this to function of just BT. But if you can, show me. Like just with recursive. Just with recursive. You just use recursive
It's like actually right. It's not
Yeah, without it.
They're the same.
I don't think you can.
I think it's even easier than this one.
Yeah, sure. I agree. But I don't think you can do this to just a function. Show me how you do it. But without a matter of recursive, right? You have to show me two recursions. That you can reduce it just to a function of BT. It's not possible. And then if you think you can, send it to me. I doubt you can. And then of course I'm saying if you have a B, right? There's a whole that is simplify the structure. It's not complicated structure. So what was I hoping what would you do? That you would go back to the method that we discussed in the lectures, but in the system set, right? That you would basically redo what we did in the lectures in the context of the simplification, right? So that in the first step, just to give you the steps of all this, right? In the first step, you say, let me do the same thing, let me uncouple backward part and forward part by defining 44 in the scalar context. Right now, C would not be a matrix, C would be a scalar. And then, of course, that means that as you get to this quadratic matrix equation that we have in the systems context, these would all be scalars. Right? A would be a scalar, B would be a scalar, C would be a scalar. So this is a standard quadratic equation, right? For which you have the quadratic formula. You can solve for C as a function of A and B. for C, that's going to be an absolute value less than 1, and that's the limit for the vector options. Right? Then you have the C, again just a scalar, and unlike what we had done in the lectures, you don't need numerical methods, right? Because you have a scalar quadratic equation, which is by the 24 that one rule, that's value less than 1. Then you have that. You turn to the forward part, and now again this is all in scales, right? So either you have that situation where that f, that is just p divided by 1 minus bc in the scalar context, is an absolute value less than 1. That of course depends on your choice of a and b, that's when the choice definitely matters. And you solve for this, again all just in the scalar context. Right? So this is at the end. F to the power I divided by 1 minus the 6 vector. The value is of future v's. Or in the case where you have that f is in absolute value larger than 1, you have to do those vector. In principle, write all the same thing as here, just everything is now scales. So that is a simplification. Four, and then the multiplicity of solutions, right, is a function of marginal differences, but not whether Vt is or is not a solution, whether Vt minus 1 is or is not a solution. The fundamental part is always the same. The multiplicity will not come in there, the multiplicity rather comes into these extraneous processes that are multiple. Right, so that's why there was a dispute. Statement that you made that is about that there are multiple solutions and one is just one of them. Cannot be because in terms of the fundamental part, we always have across all solutions exactly the same way. The only thing is that there may be additional terms in marginal differences. Any marginal difference process that creates difference process, but not in the fundamental. And that always has to be something. Try whether you can show me even the picture p is 0, then you can express it just as one of the SNL. Right? Because in essence, what are we dealing with if we have p is equal to 0? It's basically an AR model. Right? Let's just try to find the right set of slides where we look at the AR models. It's all them recurrence feedback. Right? Think about this AR model being 3. Right? Where, because we have a simple structure then here, because this epsilon is just tiny, unlike the Vt, which is itself the other. But what happens when you solve the first backward? Right? You get everything as function beyond that visualization that eventually may wash out because dependence on visualization is so weak, tends to 0. If the A is naturally less than 1, then you have this one. But this is here a part of epsilon t minus 2, which in our setup is Vt minus 1, Vt minus 2, Vt minus 2. And even if say I rewrite the leg V's as a function of just Vt, then you have all those finals in the solution. Right? So that's why I'm saying you can. But I can see you still disagree, which is great. That's great.
I disagree.
But you need to prove it.
Because ChatGPT showed me that. It really convincing to me. I don't have enough knowledge to judge it whether it's right or wrong.
No, you should aim for showing me what you think might happen.
Oh, okay.
I think
Thank you.
it will not happen that you can show me that, but you should still try.
Yeah.
You not just say, well, he said it, and so let's believe it.
Yeah. I will try.
If you don't follow my reasoning, please.
Yeah. Thank you.
Okay. So, but everybody reasonably happy about whatever you're expecting for part B, right? That you basically take the very same steps that we took when we were solving 40. Right? 40 is basically a matrix vector version of what is on the problem. So it's basically take all the same steps that we took in solving for. Split into four bracket part, solve the quadratic equation that materializes, but just all in the scalar setting. And because it's in the scalar setting, you can solve this quadratic equation anyway. Right? You don't need this equation anymore. But everything else is just exactly the same steps. Out, ordering about vectors, matrices, everything. Okay, so that's true. Now for three, I first study that, so I can cover on it. Okay, so the left-hand side basically goes to those steps, right? In the vector matrix setting of how we would be able to solve this model if it's a unique stable solution because all eigenvalues OC and of F on inside the unit circle, right? And this is certainly in terms of the vector part, the bi-dimensional stable, but also you can do the forward recursions. Because I will also matrix F tend to 0 as items. Then comes the novel part that we have some eigenvalues of F inside and the others outside. In the circle, we have a decomposition into those two blocks. For the first block, which corresponds to the eigenvalues that are inside the circle, it's the same thing as before. Applying to that block. For the second part, you need to go back. Right? I have this multiplicity of solutions. Now, what ideally I still love to see is
I'm not sure. I don't know.
this is wonderful. This is wonderful work. But still want to cover it. So what I still love to see is that it keeps them back together.
Yeah.
Right? That they keeps it back together into that overall vector Y composed of those two components. But you might say that that's too small a step, or the big part here left and right, and that's why we at the end put this all together again as a system. The only thing is, right, if you were thinking about this decomposition, you need to also partition, right, all the matrices that arise in that decomposition, right? So if
expectation. Yeah.
That's the capital.
Thank you.
And that you want a partition, right? This equation in capital.
Yeah.
That we have the first block with the eigenvalues inside the circle, the second block with the eigenvalues outside the circle. So the partition is in capital, not really directly in terms of lowercase y. Right? If it was in terms of lowercase y, it's directly pieced together. That's in terms of the uppercase y. Right? So once you have to piece those two parts together, then you need to go back to lowercase yt as a function of that partition in uppercase y, and of course the c times y dimension is unfair. But those here would really be uppercase y's, right? And then when you piece it back together, you but don't be disappointed with yourselves. And I'm sure you really are not. Because the main challenge, right, that you want to do is decomposition. The rich part you want to solve forward, rich part you want to do backward. That's the thing.
Because I imagine about when we solving the data with many columns, and I don't know how to separate them, how to decompose which one is stable, which one is unstable. So I'm confused. This is the theory and the way we can do, but for the data, I still not image.
You need to do exactly the same thing as we have done here to separate backward and forward part. Right? Once you have the forward part, again, this is not directly in terms of the y's in which you have the data. Right? In the lowercase y, you have output interest rate inflation. But the uppercase y is a transformation thereof. Right? So it's not directly output or inflation or interest rates, but it's rather a linear combination thereof. And you drew on this linear combination that's associated with ideals f that are less than 1 metric value, the forward solution, for those that associate with ideals f that are outside the circle, we backward. And then you can form back to the right? And that's exactly this transformation that you then back out again, lowercase y. Just say output inflation interest rate as a function of lag output inflation interest rates, and those parts of capital Y split into different blocks and then bring it back again. Then you have everything.
Let me try.
Any other problems or questions on that part? Well, I think that's good, right? So, hands-on problems for this problem set. It's split in 2 parts. Right? One is that we have a model that's containing more equations, more variables than the 3 equation output inflation interest rate model that we have in the lectures. So that you see we have this specifically also modeled the capital stock, entry into production, right? The capital stock is the second factor of production beyond labor input, that would be motion for the capital stock, that would be think about what's output, it's not just consumption anymore, but also investment. You have nonetheless still those 4 equations that we had before, or the equation for consumption, physical relationship between the modern policy, associated processes, and equation that just like the equation the labor hours that households will want to choose. It's just that in this context where you do have to compare the stock of capital, the labor hours that you choose will also be dropped from somewhere. That's part of the Marshall Plan. So what you would want to do in this context, I'm not sure whether one of you wants to show us some sort of solution, but what you would want to do in this without post as an M file is that you take off from that M file that we had in lectures and document that.
But can I ask a quick question?
File.
Can I ask a quick question?
Yeah, sure.
Because we have 9 equations, but then only 7 endogenous variable. So in our YT, how we actually can handle it? Is it supposed to be the what would be the dimension of our system?
Let me show you the game file that I'm supposed to answer your question. So I have, as you just said, like 7 endogenous ones. Right? And that's the dimension of the system. Of course, you could think about ways of can I possibly remove some of those equations. Therefore, some of the endogenous variables might not be back as well. This is really generally possible. I just wouldn't do it because that's potentially our code for it. I would rather just take all the endogenous variables and set up the system. Right? And so that's what's in here. Then you have those 7 by 7 matrices. The contemporaneous part of the leg part of the right, and that you then go through all those equations, map this very carefully. That's the main thing. Make sure you take the card on the left side, what's on the right hand side, and make some shifts relative to the formulation in the problem set, and set up all these matrices. Right? So that if you were to go through these matrices row by row, that just picks up always one of those equations. And then you plug in the parameter values, right? That are given. I have that at the top. And then you can copy and paste what we have in the matrix. That's matrix C to calculate the matrix F, and therefore establish the involves. One here, F, then bit, you get the results that you have the eigenvalues of the C matrix. There's now 2 non-zero ones. If you remember one from the lecture, one eigenvalue only non-zero that was coming because we had this interspace moving from one to the policy. Right, so that we have a reflect official interspace. Right, we have here a second non-zero eigenvalue because of the law of motion. Capital stop and key does not depend on the capital stop and key, and therefore does not the capital stop and key depends on the capital stop and key minus 1. But that's the second zero eigenvalue in the C matrix, and at least for the parameter values given the eigenvalues of the F matrix are the values of this solution. Again, I'll post this, of course, to the website. But I think the main thing here is don't would be my suggestion. Don't try to eliminate some of the equations as a function of the others, because I think that's a very important procedure. Take each and every equation and then make sure that you map very carefully those coefficients that appear in that equation. We have done that because the code that we had in the lectures, right, to calculate the C and F matrices as a function of A and B is generic to our eigenvalue equation system. But what we have is so we can have more of course, you can use the calculation to think about the structure of probabilities.
In our system of the matrix, how we actually handle the two last two, how we enter into the
for the exhaustion right? That would only enter in terms of the WT, right? But the WT you need not per se to calculate the C matrix to calculate the F matrix. That would just come in if in the end you also want to say, well, I want to write the solution directly in terms of functions of the elements in that exhaustion processes. But here, right, when we look at the problem structure, all I wanted to do when obtaining the solution is to obtain the matrix. Right, and so answers could have written down anything here, we would have effected the matrix here. If I would want to write everything as a function of W's, right, we need to know, of course, what is the specific structure. Like we had in this solution over there, that the VT was in ER1, and then, of course, to calculate future expectations of the V's, you use that ER1. It would be a little bit different if it was in ER2 or it's a number of 1 or 5, right? But in this problem, I'm not asking you to solve out those future expectations of the examples variables. And so, any different categorization you have here matter, as long as you just want to the same attributes.
And what would happen if when we run the C and the F, if there's a conversion?
Then you have a problem beyond the scope of this course. Like that I haven't given you methods for that can work out, because I'm looking at this set of versions here, still emphasize the number of iterations of this conversion. I would dare say it won't happen for any ESG model. It's quite subtle, you know, if you want to analytically develop necessary sufficient conditions on the images that the solutions for C and F are well defined. There is some work in the literature that does that, but those are not very transparent conditions seen on the images. But in practice, I haven't seen any ESG models. I could still say, but if it happens, we could also discuss calculating C and F using a so-called generalized eigenvalue eigenvector. There are techniques out there to solve that quadratic equation. It doesn't happen for any instrument I'm aware of. We have discussed that in the course. So I think it should be. I mean, another question, right? That we think about, but not from that all of a sudden the C and F don't converge. If it happened, then I would, if I was you, double check my definition. Okay, so that's the first problem that is hands-on using software, and then comes the next one, which is relative to, and we had some discussion with Marcus already, while we were working on the whiteboard, so this is for your benefit. What are the changes? This is done in terms of consumption, right? Because the original model actually had consumption, but in this original model we then used the fact because there's no investment, there's no down expenditure, there's no trade balance consumption equal to output. This is just writes in terms of consumption directly. Now, of course, interpreted that will matter, right? Because you probably studied in the macro or foundations course that consumption tends to be smoother than income, right? That individuals over time smooth consumption, that in good times they will ideally at least set aside some income that they will need for current consumption to save for the future, and then use those savings again, right? When income may not cover the consumption needs, and therefore consumption jumps smoother payments. So in principle, this is not innocuous at all to say let's now just use consumption power and output, but in terms of our structure, which this is actually because in the model, consumption systems. So that's the one change, and then the second change that we're going to discuss is that we now have here the purposes variables that are shocks to consumption, but now we have this shock to the Phillips curve relationship, and as in the lectures also shock to that all RC. But that's it. Right, so the only changes again that we replace are consumption, and that we get the solution versus all shocks. So, of course, I'll also post this M file, and the corresponding mod file for this problem set, in terms of the mean underscore BSGE file now. No change, right, in terms of substance, except because you have to call up now the files that, in terms of the mod file, to the formulation of the problem set. But otherwise, no change in the main file. In the transform file, because the changes that in our consumption output, but per se, this uses in equation 24 LC instead of LY, otherwise it's just so nothing substantive really. In terms of those changes, if you go to the mod file, it will go to the mod file that I will post, but it's trying to, in essence, keep things as analogous to what we had in the lectures as far as possible. But of course, you have, for example, this additional persistence throughout the shock. Right? And then, as we already discussed before, in the absence of other prior knowledge, I just say, don't have any knowledge that this shock to the Phillips curve will have a different structure than the reference shock or the policy shock, and so forth. Otherwise, I think it's substantially remaining the same as on in the lectures do file. So when it was the first time around that you run this, you will need to generate this so-called news file. Here, the second time around, you run it's a CMR. That, and at this point, everything should be ready for execution. So I run this, of course, this is going to take a little bit, my path is not set up. Let me do this. I think the lectures we had used at least 24 people. Do I recall that correctly? Does one of you remember? I think that's what we had done in the lectures. And so if one change the path and all of that, then we just start
Mình chưa cài được.
where I have already set up the path and that in the path for 25p.
Đi. Chưa gì em thấy.
Sometimes the longest reading period with better is just what the ultimate taking on with Alright, now I'm ready for B open, right? I'm just gonna
Số môn này chắc liền luôn.
Again, this main underscore BSG, underscore problem set. Right. Percy, I think at this point you are having seen this one before the lectures, right? So, you'll be, I can show it to you in the end again once that's given us some parameter values, but just to save a little bit of time, right? I basically only copied those parameter values back into the new file, right? As we had done in lectures, because that gives us the forecast in the same format as all the other models that we had, VR, models, and so forth. Right, and so in that true file, you have the parameter values that I'm getting already in line 7, 6, 5. I constrain all of the parameter values because this is not convergent in the state otherwise. So that's the only way to get the convergence. Exactly those parameter values that in a few moments you can see come out of the estimation between the red. Right, I just enter all of these, and then that data is an estimate of model. What I've stated that estimates, what is it really? It's just estimating standard errors for the shocks. To be the one policy consumption. That's all it's going to do. And of course, the variance of those shocks doesn't affect any forecast, right? So that is about that maybe comes up with different variance of shocks than what we have in that. Still learning that. Well, now we have it, right? So
can I ask a little bit on the data code? The part when you put like constraint 1/2 or constraint
in Stata,
yeah, the Stata
I
part.
just want to convince you, but you're already convinced that the values that are in Stata otherwise are the ones that you see here in the MATLAB display. Okay, so then I can go back to Stata, and please tell me again, where's your concern here?
The last line, the in sample, the last part, when you put the constraint, then open bracket, 1 divided by 10 or 1 divided by 2.
Which line are you?
So line 72 and 94.
Okay, so the difference here is that initially, right, I would still try in Stata to estimate all parameters except beta and phi, which I constrain to beta for 9 and 1 respectively. And then in order to use those constraints in the BSP estimation, I use that as an additional specification. 1/2 means I use constraint 1, I use constraint 2. Now, in the final estimation, where we bring in all these parameter values to MATLAB, right, I have not just those 2 constraints, but 8 further constraints on 8 further Martin parameters. Number them 1 to 10, and then say, well, Stata, please use all 10 of those constraints, 1/10. That is what you could in bricks would do. You could specify a constraint, but not use it. That you could say, for example, constraint 1, 2, 3, 4, 5, all the way up to 10, and then if you set here constraint 1/8, you just wouldn't be using the 9s and the 10s. That's part of this command syntax that you have to be careful, even if you wrote down the constraint, Stata may not use it, unless in the option of ESG you call out this constraint. You can call it out. So, all right, if I now execute this, using the log files, we're starting again from the beginning. Then you see these are all the live results. We are loading the data set up to line 42. Then we use in the estimation the consumption gap in MATLAB, so we have to use in Stata 2, and in Stata you get the HP filter using the command TS filter HP. And that's indeed extracting the consumption gap, and you're all going to be convinced in line 61, we also just plot this consumption gap, so that we can do that. And this is quite stunning, of course, graph that simply tells you in the pandemic, consumption was cut by about 12.5–13%. And that's, despite the fact that we just discussed, consumption is relatively smooth series, right? But in the pandemic, in the US, food consumption fell by about 12.5%. Now, could discuss at length whether that was for reasons of loss of income or whether it was for reasons of lack of consumption opportunities, right? You had this pandemic both. That the restaurants were closed, the movie theaters were closed, there were no concerts, and so on and so forth, right? So it's of course a mixture of both. Whereas typically, when you think about this fluctuation in terms of the business cycle, it's probably because of adjustments to income, not because you cannot go to your favorite venue or to have consumption. That would be within the pandemic, and therefore it's also not surprising in a way that its effects are much larger. All right, now that's one, the estimation of all these 10 constraints, right, so that we have again all the parameter values in Stata. For our model, that converges to right, it gives you really as the only estimated parameters times in standard deviations. That's it. The others are coming from out of the dynamic estimation. And so now we can plug that back into the forecast. And that is a copy and paste from what we had in the lectures. The same command syntax with the forecasting suite of commands that we had in the lectures within Stata. In the first step, we want to calculate from this DSGE model and the forecast one and multi-step ahead. You see that the one step ahead forecast errors, but you don't see that obviously maybe as in some of the other graphs that we have for other models. But what I want to say is the one step ahead forecast errors, like for all of our other models, are realizations of the shocks, nothing else. Whereas for the multi-step ahead forecast, basically forecasts from, we call that our incentive period ended in the last quarter of 2021. We forecast that forward and cannot fully anticipate the drop in consumption expenditure that we had from early 2023 onwards. Why did we have this drop? Probably in large part because of the inflation crisis. And therefore, of course, people would have to adjust their expenditure on consumption overall because of the rising rates of inflation. And so, if we now did a comparison across all the other market classes that we had before to get a sense as to how strong are those forecasts, and to generate forecasts from all the other models, because within the file we have the lag or the selection for each and every model. That's why this is going to take now some time to run before it produces results. But we're on the way, so we need to be a little bit patient, and once we have lag or selection estimated models across all different model classes, we are ready to compare the forecast. Maybe let's first look at the one step ahead forecast across the different model classes. That's in lines 181 through including graph 188. And maybe with the iMetric, what you might suspect in terms of the one step ahead forecast, orange, green, coming out of the AR, although we are more past doing a bit better than that means in the schema, but of course we can compare that in terms of the mean squared forecast error. That's in the last two lines of the blue file. If we calculate that for each and every model structure, and then compare it across different model structures. table back in the what one is it? Small, the smallest group means better, right? Comes from the lima point zero three eight rounded, and that's smaller than for any other model, right? Because can happen, because it's not that implausible that consumption would have a unit as well, just like output. So it's not a completely implausible model, but that seems to, in any case, best one step ahead forecasting. If you compare the multi-step ahead forecasts, second graph in this blue file, then, of course, depends again a bit about what is the exact number of steps that you want to take out of a sample. But if, for example, look at the reaction model, that is pretty good still, right, in terms of the one step ahead forecast. It is for much of the outer sample period, under predicting the actual values of the consumption gap, but then over predicting for the last 2 or 3 quarters. In terms of coming close overall, probably with the iMetric, of course, a very different model than the REMA model, but what does it reflect? That we choose the ARMA multi-step ahead, because basically it's consumption gap returns to just about zero. When it was zero is the mean of the consumption gap series. So it reverts back to the mean of a sample, the actual consumption gap, and that's why the mean reverting model does the best. Model, just univariate backward model does best because it happens that in our sample period it's just kind of a shootback. But what's more, because this is not generalizable to other sample periods, other variables and so on. This is, as we have expressed so often in the course, variable sample specific what does the best, and as we have seen, you can differentiate if one goes as multiple step forecast. Okay, so I think that's it on the problems. So if you allow me to leave half past, I would appreciate that. But if in the meantime we still have some more questions, then we can do another 15 minutes. But if I've answered all your questions, then there's no need to extend the work. Any questions still that you want to pose today, which haven't been asked yet? Online, of course, online is also allowed to ask questions, right?
So,
I'm
happy with all of your problems and solutions, but I just want to ask about the paper that we need to sign, when we sign that, and when we, like the time that we will sign the project declaration thing, after or before that time, or we can send it any time?
Afterwards.
After.
Yeah. You don't need to sign this right away, because then I don't think I could hold you liable, because you didn't know yet what you would do. So just submit that all in one go. All in one go by the time you submit. But again, even if you submit early, you should not answer questions from anyone else. Not because you per se violate the statutory declaration anymore, but because that person whom you respond to would of course violate the statutory declaration, right? But yeah, absolutely sufficient to submit that together with all the other files at the time of this. write a response online, there's more likely such a response. You want to try?
Hỏi thử nó hỏi gì.
No, doesn't seem to be the case, right? There's some oh, wow. That's great. Thanks very much. Much appreciated. So, if that's it, then we have a few more days, right, until next week,
Thank you.
Wednesday. And of course, I put up this crazy hour when this project is posted, so that I don't have to get up at 3 at night to post it for a feasible time for you. But I'm not suggesting that you should get up on Wednesday at 3 a.m. in order to be able to do the project, but just to make it transparent, right? And then you don't say, well, somebody else told me I was working on this for 5 hours, then you get up at 8 or so and then download it, then you don't feel at a disadvantage. You have that possibility. But I don't think